We're diving into a really fascinating, kind of counterintuitive idea that's making waves in the world of artificial intelligence. It's this notion that to make an AI smarter, well, you might actually need to teach it with less.
I know it sounds completely backward, doesn't it? But some groundbreaking new research is suggesting this might just be the key to unlocking an AI's real ability to reason. So let's break down exactly how and why that is.
All right, to get our heads around this paradox, we first have to talk about a huge problem that trips up even the most powerful AI models, especially when they're trying to tackle complex reasoning. It's a dead end, and it's called reward sparsity. Okay, picture this. Imagine a math student trying to solve an incredibly hard problem. They get it wrong, and the teacher just marks it with a big red X. That's it. No feedback, no notes on which steps were right, no clue what went wrong. That, right there, is reward sparsity for an AI. It's just stuck in this cycle of failure with absolutely no idea how to get better. So you'd think the logical solution is to just give the AI more help, right? Flood it with hints and examples and partial answers. But this is where things get really weird. Turns out that common sense approach doesn't just fail to help. It can actually make things worse. The researchers who wrote this paper figured out there are three main reasons why just dumping more information on an AI can totally backfire. Let's walk through them. So first up is something they call the critical segment effect. It turns out for any given problem, there's often just one little golden nugget of information that unlocks the whole thing. Once the AI gets that one key hint, its performance just skyrockets. Any other hints you give it after that, they provide almost zero extra benefit. Most of that help is just noise. Second, you get this problem of cross-hint inconsistency. When you throw too many hints at an AI, they can actually start to contradict each other, or maybe they suggest different, conflicting ways to solve the problem. So instead of clearing a path forward, you're building this confusing maze that makes the AI's job even harder. And finally, there's just a really simple, practical issue: the efficiency trade-off. See, creating all these extra hints is super expensive. You often need another, even more powerful AI to act as a teacher, and that costs a ton of time and an insane amount of computing power. It's just not a practical, scalable solution. So if more isn't better, then what is? Well, the researchers came up with a completely new philosophy, a whole framework built around this minimalist approach to teaching AI. And they call it KnowRL. And I love this quote from the paper because it just nails their whole idea. It's not about the quantity of help you can inject. The real goal is to provide the absolute minimal information needed to get the AI unstuck, and then let it figure out the rest for itself. And that's KnowRL, knowledge-guided reinforcement learning. It just flips the whole script. Instead of asking, how much help can we possibly cram in here? It asks, what is the smallest, most powerful piece of information we can provide to unlock learning? It's all about quality, not quantity. So how does it actually do this? Well, think of every single possible hint or example as a tiny individual knowledge point, or KP. KnowRL's entire mission is to sift through all of them to find the smallest, yet most powerful combination to give to the AI. It's basically precision teaching, but for machines. Okay, so the plan is to find the best, smallest set of hints. Sounds easy enough, right? Just test all the hints, find the bad ones, and get rid of them. But this is where the researchers found something truly bizarre, something they call the pruning paradox. So get this. You'd assume that if removing one unhelpful hint makes the AI perform better, then removing a whole bunch of unhelpful hints would make it perform even better, right? Well, that's not what happens. Removing them all together can actually make the AI's performance get worse. It's wild. And the data from this study shows this so clearly. The blue line you see there represents the probability of this weird, paradoxical interaction happening. And notice how it stays high no matter how many hints get removed at once. It just proves that trying to prune hints in big groups is incredibly unpredictable. So why? Why on earth does this happen? It's because the hints aren't independent. They can rely on each other in these really subtle, hidden ways. Removing a bunch of them might feel like you're just trimming away useless info, but you could actually be breaking a fragile, hidden chain of reasoning that the AI was secretly using to get to the right answer. So how do you solve a puzzle like that? How do you find that perfect golden combination of hints without accidentally breaking everything? The researchers came up with a really elegant solution. They call it constrained subset search, or CSS. It's this really smart three-step process. First, it looks at every hint that could possibly be helpful. Then it gets rid of the obviously bad ones right off the bat. And then, and this is the key, it searches for the perfect combination only within that much smaller, high-potential group. It focuses the search right where it matters most.
And the numbers really show why this works so well. I mean, look at this. Giving no hints gets you about 60% accuracy. Throwing all the hints at it barely makes a difference. But look at their CSS strategy. It uses just about 2.5 hints on average, but it gets the highest accuracy of them all. It really finds that perfect sweet spot.
So, we get to the big question. Does this minimalistic approach actually create a smarter AI in the end? Well, the final results are, frankly, pretty staggering. So after being trained using the KnowRL framework, the AI model's average accuracy improved by over 9.5 points. And get this, that's without being given any hints at all during the final test. This proves the AI genuinely learned how to reason. It didn't just learn how to follow a bunch of instructions. And then when that same smarter model was given those minimal, perfectly chosen hints during the test, its accuracy shot up to over 74%. That set a new state-of-the-art performance for an AI of this size. So yeah, less really is more.
And this visual really says it all. The blue bar on the far left represents the original AI. It got a huge number of problems completely wrong. The green bar is the new KnowRL model. It just completely flips that distribution. It goes from being mostly wrong to being overwhelmingly right.
Which brings us to a really fascinating final thought. We've just seen that giving minimal essential information is the key to unlocking an AI's ability to actually reason on its own. So it leaves you with a question. If the best way to teach artificial intelligence is with less, what does that say about how we learn?